Okay. Today we discuss the topic is classification of DC generator. In parallelly we discuss the DC motor concept. So in based on excitation, DC generator and DC motor are classified into two types. That is nothing but one is separately excited. Second one is self-excited. One is separately excited, second one is self-excited machine. So what is a separately excited? What is a self-excited? Separately excited in the sense of we are nothing but in DC machine the construction parts are stator and rotor. In stator side we are connected to the field winding. The field winding connected to the additional some supply. It is nothing but the double excited. So field winding we are connected to the additional supply, that is nothing but the separately excited. In the case of field winding we are connected to the additional supply. So that is nothing but the separately excited. Like as they are the field poles. These field poles we are connected to the additional supply. So that is nothing but the separately excited machine. So now self-excitation machine does not need to the additional excitation. It is nothing but simply single excitation. Only we are connected to the prime mover connection. So due to the prime mover connection, it will be create the generating EMF. That is generating EMF. It's transferred to the terminals and load side. So in this case, so it is a self-excitation, does not need to the additional supply. So based on, so it will be self-excitation. Why it is self-excitation is nothing but, so permanent magnetic poles are used. In this case, permanent magnetic poles are used. These permanent magnetic poles are creating some residual magnetism. Residual magnetism. Due to residual magnetism, armature is rotating. Due to residual magnetism, armature is rotating. There is a based on self-excitation machine. If it in case of to lose the residual magnetism, the terminals are reverse connection. When the terminals are connected in reverse, that case of residual magnetism will be lost. So we gain to the residual magnetism. The permanent magnetic poles are connected to the some external battery supply is connected to the field poles. Then again regain the residual magnetism. When the residual magnetism is present, it will be act as self-excited. Okay, that is a self-excited machine. So we need to the what is the residual magnetism. So we reference topic is BH curve. Once follow the BH curve topic, we can clearly we can clearly find out the residual magnetism concept. Okay, so based on, so these are the self-excited. Again, based on connection of series and armature winding, it is classified into different type. That is the one is series generator or motor also. In parallel, we discuss the motor concept. Second one is shunt generator and motor. Another one is the compound generator and motor. Again, compound generator and motor is again two types. One is short shunt and another one is a long shunt. Short shunt and long shunt generator or motor. So these are the classification of DC generator. In parallelly DC motor. Now first we discuss the topic is separately excited generator or motor. Parallelly we discuss the motor also. So first we discuss the separately excited motor. Separately excited generator. In parallel, then after we discuss the motor also. So first we discuss the separately excited generator. In separately excited generator is nothing but field winding. So DC machine is basically two parts. One is the stator part, another one is the rotor part. So rotor part is consisting of armature winding. So these are the rotor. So into the rotor we connect to some armature winding RA. So in this case some current will be flowing, that is a IA current, armature current. So this armature current is connected to the terminal voltage load. This VT is nothing but the load, that is nothing but the terminal voltage. Let us the field winding. In field winding is separately connected to the excitation. Separately connected to the excitation. So this is nothing but ISH. So this is nothing but RSH. So we can find out the relation, EG relation. So voltage equations. So current and voltage equation. First we can find out the separately excited. So EG equation, here we are connected to the some prime mover. So this prime mover, it's create the some EG generating voltage. It's prime mover, it's create the some generating voltage. So here we can observe separately excited nothing but these are the one excitation. Prime mover is connected to the one excitation. Again here some battery supply. Here we are connected to the some another one excitation. So this is nothing but the simply double excitation machine. It is not a single excitation machine. It is double excitation machine. One excitation coming from the mechanical supply through the prime mover. Another one is the battery connection through the field winding. So in this case, if we can find out the generating voltage EG. So generating voltage EG. So what is the generating voltage EG? So we know the EG is equal to pi Zn by 60 into P by A. So this is the generating voltage. So now coming to the terminal voltage VT. So what is the terminal voltage? This terminal voltage is nothing but the output. Terminal voltage is nothing but the output. So what is the output? Output is equal to always input minus losses. So what is the input here? Input is nothing but generating voltage EG is the input. Minus losses. What are the losses here? Some current will be flowing through the flowing from armature winding to load. So here some resistance drop will be there. So losses is nothing but drop. So drop is nothing but I into R. So here some current will be flowing, that is current is IA and drop is equal to RA. So this is nothing but the separately excited. So we discuss the only separately excited machine. Again here some again another one drop will be there. So one drop is equal to I into R drop. Another one drop is brush drop. That is a brush drop is equal to, so 1 volt per each brush. 1 volt per brush. Here we are connected to the two brushes. Again minus brush drop. So when EG minus IARA minus brush drop, so that is nothing but the whatever the result will be coming, that is the result is nothing but the terminal voltage VT. So again we can write as EG is equal to, so EG is nothing but input is equal to output plus losses. So what is the output? Terminal voltage plus losses. What are the losses? IARA plus brush drop VD. So this is the separately excited machine. And in practically we can find out the separately excited machine. At the time of starting, we are connected to the two resistors. One resistor in series with the field winding. Another one resistance in series with the armature winding. So at no load condition, at no load condition, like as at starting condition, at starting condition. So we are connected to the two resistors. One is armature resistors, that is RA. So armature in series with the one resistor in series with the armature, that is we are called this armature resistance. Another one is the RSH. RSH is nothing but, so these are the RSH. Whatever the resistance connected in series with the field winding. So at the time of starting, armature resistance should be maintained to the maximum position, and this will be to be maintained to the minimum position. In practically, these are the at the time of practical case. Now up to here we discuss the only EG relation, EG versus current relations. So what is the EG is equal to VT plus IA RA plus VD drop. So next we go to the self-excited generator. The self-excited generators are classified into again three types. One is short shunt, long shunt. So one thing we forget the one concept in separately excited DC motor. So separately excited DC motor in separately excited again. So DC motor. Okay. Finally, we are given the conclusion for the DC motor topics. First, we discuss the DC generator topics only. So next topic is separately is completed. Next one is self-excitation machines. Self-excited first one is series shunt compound. So first we discuss the series generator. Series generator is nothing but we are connected to the armature winding and field winding. Only two windings. One is armature winding, another one is the field winding. Both are connected in series. Armature winding and field winding. So armature winding and field winding both are connected in series. That is the RSH. So there is some prime mover. Okay, here they are the armature resistance. So here we produce some voltage EG. So here some flowing to the current IA. So this is ISC or ISH. Sorry, ISC. So here we are connected to the load terminal VT. Similarly, we can find out the equation, generating equation. EG is equal to EG is nothing but the input. Input is equal to output minus drop. So what are the drop? Here drop is consisting of VT minus IA RA drop. So here IA is equal to armature resistance is equal to armature resistance and series field resistance or load resistance. We are consisting of load resistance. All are in series. In series, current must be same. So here all are in series. The current must be same. So therefore, we can find out the VG is equal to VT minus drop is equal to I into R. So here total resistance, whatever the total resistance, here RT is equal to RA plus RSC. So total resistance RT is equal to RA plus RAC. So there is a current is equal to, we can find out IA is equal to RA plus RAC again minus BD brush drop. So that is nothing but the VG voltage. So again we can find out terminal voltage VT is equal to EG plus IA RA plus RAC plus BD. Simple thing. So VT is nothing but output. Output is equal to input plus losses. When we can find out the output is equal to input plus losses. So this is nothing but the series generator. So next we go to the shunt generator. So we go to the shunt generator. So what is the shunt generator? Second one is the shunt generator. shunt generator. So field winding is connected in parallel. Shunt is nothing but the in parallel. Armature winding and field winding both are connected in parallel. That is nothing but the shunt generator. So we are connected to the VT terminal voltage. So here armature resistance. So we are connected to the some prime mover it is connected to the some prime mover, so it is RSH, it is RA. So in this case some current will be flowing, that is IA. So in this case some current will be flowing ISH, it is the IL. Again we can find out the here some voltage will be produced, that is EG voltage. So we can find out EG is equal to VT minus drop. VT minus drop. VT minus. EG is equal to input. Input is equal to output minus. That is input is equal to output plus drop. Input is equal to output plus drop. Input is equal to output plus drop. So what is the output? Output is equal to VT. So what are the drop? Drop is equal to, in this case, we can find out. So these are the node point, consisting of node point. So what is the node point? IA. IA is the entering current. So IL plus ISH, these are the leaving current. Sum of the entering current is equal to sum of the leaving current. We satisfy the KCL. So in this case, we can find out ISH. ISH is equal to V by RSH. VT by RSH. Whatever the terminal voltage in same voltage is appeared in RSHs because of terminal voltage, armature resistance and RSHs. Both are all connected in parallel. In parallel, voltage must be same. That case of VT by RSH. Here also voltage must be VT voltage is present. At the condition also VT voltage is present. So that case of VT by RSH. So we can find out IA. IA is equal to, what is IA? IA is equal to IL plus ISH. IL plus ISH. So let us, we can find out the drop. So what is the drop? EG is equal to VT plus drop. The drop is equal to only armature drop. That is IA. IA plus IA into RA plus brush drop. or VT is equal to terminal voltage is equal to EG minus IA RA minus brush drop. Again we can write this shunt generator equation. So we can, one thing we can observe in series and shunt. In shunt is always shunt winding. Shunt winding always thin layer and more turns. But series winding thick layer and less turns are present. Okay, so shunt is a very thin, it is very thin, but more turns. When we are using for the series field winding, that is a thick and less turns. So at a time we are connected to the shunt and series, that is nothing but the compound generator. At a time we are connected to the series and shunt windings, that is nothing but the compound generator. So let us now compound generator again is classified into two types. One is now compound generator, third one is compound generator. Now this compound generator again classified into two types. One is long shunt and short shunt. Okay, long shunt and short shunt. First we discuss the long shunt generator. Long shunt generator. Long shunt. It is similar to long shunt. It is similar to shunt generator. So what are the difference? We can find out. So here armature winding. Here armature in series with series field and shunt field. At a time we are connected with series field and shunt field. So we can observe the series field and shunt field. The series shunt field has having more number of terms. More number of terms. These terms are very thick, little bit of thick. And where we are cased of series field winding, these series field winding are less terms and very thick. It is a thin, it is a thick. So in this case, again we produce the armature winding. Internally we are connected to the armature winding. So some external prime mover is connected. So due to the external prime mover, it will be generated the EG. So this EG is transferred to the load. It is the load side, that is terminal voltage. Terminal voltage. So they are the shunt field RSH. In this case, we are current ISH. This is nothing but RSC. So this is IL and here some current IA and ISC. So here IA is equal to ISC because of IA and ISC in series with current. In series, current must be same. Now again, same as node point. This is consisting of node point. Sum of the input current is equal to sum of the leaving current as per KCL. So in this case, sum of the input current is equal to IA. IA is equal to ISC. So that is nothing but ISH plus IL. So what is the ISH? So ISH, voltage in parallel with the shunt field resistance. So that case of we can write as ISH is equal to VT by RSH. VT by RSH. Let us we can finally write the terminal voltage equation. Terminal voltage equation VT, it is the output voltage equation. Output voltage equation is equal to input voltage EG. Output, we can find out the output equation is equal to input voltage, input minus losses, minus drop. So we can write as VT is equal to EG minus what are the drops here? Some IA is equal to ISC, that is IA is passing through armature resistance plus series field resistance. Armature resistance and series field resistance. Again we can draw the BD, we can write the BD, brush drop. Brush drop is in the question will be given to the brush drop, we added to the brush drop, otherwise does not consider to the brush drop. So there the output equation. We can write the input equation EG is equal to VT plus IA RA plus RAC plus BD, brush drop. So this is nothing but the long shunt generator. Again we can write the another one terminal is short shunt. Another one is the short shunt generator. So short shunt generator is nothing but similarly same as long. What is the difference between the long shunt and short shunt? We can observe short shunt. These are the armature winding, series field. So in this case we are connected to the armature. In this case we are connected to the armature. So let us from in middle part, in divide into one terminal is divided into series field and armature. Series field and armature winding is splitted. So this point is nothing but we are consisting of short shunt. This point we are consisting of short shunt. Again we go to the terminal voltage VT. So here the current is IA, here the current is ISC, here the current is ISH. So this is terminal is RSH. Okay, here IA, IAC, RAC both are in different. So from this case we can find these are the node point. So at the node point what happened? These are the entering, so these are the leaving, these are the leaving. So let us IA is equal to, IA is entering current, so ISC, ISC and IL both are in same. So here ISC is equal to IL, both are in same. So ISC plus ISH. Okay, but we can find out here ISH is important. So how to find out the ISH? ISH is nothing but, so for example these are the, at the point is input, this terminal is input, so this terminal is output, so this terminal is, where is this point? For example the point 1 అనుకుంటున్నా, where case of point 1, what is the point 1 is input, that is the input is equal to output minus drop. So what are the drop here? So that is the output, here some voltage, that voltage V. Okay, we can find out the voltage at particular, so we can find out the input voltage at point 1. So that is the output voltage we are taken to the VT, so minus, so they are the input. Input is always taken output plus drop. Input is equal to output plus drop. So what are the output? VT. So what are the drop? ISC. ISC is equal to IL. ISC into RSC. So this is nothing but up to voltage, because of these two are in series. From the, in this case RSHs is parallel. So that is case of input is equal to VT plus ISC RSC. So we can write as ISH is equal to VT plus ISC RSC by RSH. So this is the only difference between ISH. So let us, we can find out VT. VT is equal to output. Output is equal to input minus drop. Again input minus drop. Here input is equal to VG. VG is equal to input. So output is equal to input minus drop. Here output is equal to terminal voltage. Input is equal to VG and drop is equal to here. What are the drop? IA RSC drop. IA is equal to IL minus, sorry, ISC RSC drop. ISC RSC drop minus IA RA drop. So again we can find out EG is equal to VT plus ISC RSC plus IA RA. Again we can add the BD, brush voltage drop. BD is equal to brush voltage drop. Here also we are consisting again BD voltage. Okay, this is nothing but the voltage relations of self-excited generator. In parallelly we can write the motor's equations. Motor equation in parallel similarly. So we go to the last two first. First we write the short shunt generator. Same concept. What are the difference? What is the difference? Motor is nothing but electrical to mechanical. Electrical to mechanical. So in this generator is nothing but mechanical to electrical. So up to here we can find out. So here we are connected to the some prime mover. This prime mover is equal to mechanical supply. At mechanical we generate some voltage EG. So there is nothing but we are consisting of input. VT is equal to output. Let us first we started with short shunt generator. Short shunt generator EG is equal to VT minus ISC RSC IA RA plus VD. Now we are consisting of short shunt motor. So motor is nothing but what happened? This is the input. Where it is the input? Here input is equal to VT. The current direction is reverse. So here current direction is the motor directions. Here current is in this direction. So ISHS does not change the current direction. So IA is equal to in this direction. So here we can produce the VT is connected to the this prime mover will be rotating. That is a mechanical supply. This is the output. So let us here again same current equation. Now here we can find out the current balanced equation. So input current is equal to IL is equal to ISC. So input current is IL and output current is equal to ISH plus IA. ISH plus IA. So in this case we can find out IA is equal to IL minus ISH. IL minus ISH. IA is equal to. Let us similarly ISH. ISH is equal to, in this case the drop will be present because of this is the output. Previously this is the output. Now it is the input. So we can find out the output is equal to input minus losses. Input minus drop, that case of here simply you put a minus. So here output is equal to, in this case what is the output? Output is equal to EG. Output is equal to EG. This is the output. What is the input? Input is equal to terminal voltage VT. So again, so EG is equal to VT minus drop. So again we can write as here VT is equal to EG in the sense here we can take as back EMF. In this case EG is equal to EB. VT is equal to VB plus drop. So this is nothing but the short shunt motor. And similarly we can find out the long shunt motor. So we can change the current direction. So only these two or current direction will be changes. So again we can find out here input current is equal to output current. We can find out here entering current IL is equal to IA plus ISH. So let us IA is equal to IL minus ISH. So here input. So simply we put plus, here we put plus. In this case we can put off minus. That is for here back EMF. Simply we can change off back EMF. So that is back EMF. So what is this? This is nothing but the input is equal to output minus drop. Output minus drop. This is nothing but the long shunt generator. Similarly we can follow the series generator and shunt generator. So finally we can write the equation at a place. All the equation, final equation, series generator and motor. So generator equations and motor equations. Generator equations and motor equations. First one is separately excited, so not need, and we can follow the self excited. First one is series generator. Second one is shunt generator. Series connection, shunt connection. Next one is compound. Compound is a short shunt and long shunt. Short shunt and long shunt. So in this case series generator is nothing but input is equal to, always we can follow the formula, input is equal to output plus drop, or output is equal to input minus drop. Here generator input is EG, output is terminal voltage. In motor input is terminal voltage, output is generating voltage. That is a back EMF. Input is back EMF. First series generator we can follow the EG EG is equal to input, input is equal to output, output is equal to which one? VT. So what are the drops here? Input. We can find out the input. Input is equal to output plus drop. So what are the drops? In series only one drop, that is nothing but the IA or RA plus RSC plus brush drop. So in this case, what is the current relation? IA is equal to IL plus IL is equal to ISC. All the current are same. So similarly, we can find out the motor equation here. Input is equal to VT, output is equal to EB. We can find the EB equation, output equation. Output is equal to what is the input minus drop. See, input is equal to VT. So what is the drop? IA, RA plus RAC minus brush drop. So here also same, IA is equal to IL is equal to ISC. IA is equal to IL is equal to ISC. So next we can find out the shunt. So shunt is equal to EG is equal to VT plus drop. So what is the drop here? IA RA drop. Here we can find out the IA. So what is the IA? So here what is the direction? So this is the direction. ISH IL. So let us IA is equal to what is the IA is equal to IL plus ISH. So from the case we can find out ISH is equal to V by RSH. VT by RSH. So this is for shunt generator. Again shunt motor EB is equal to VT minus IA RA. So in motor direction what is? This is load IL, this is ISH, this is the current in this direction. So we can find out IL is equal to IA plus ISH. Let us IA is equal to IL minus ISH. So what are the ISH? ISH is equal to VT by RSH. So this is nothing but the which one? Generator, shunt generator. Again we go to the compound generator. First one is short shunt generator. Short shunt generator. So short shunt is equal to EG is equal to short shunt. What is the short shunt direction? VT plus short shunt. We are consisting of short shunt RA plus ISC RAC plus BD, brush drop. Okay, so here IA is equal to what is the IA? Here IA is must be same, that is IA is equal to IL plus ISH. Here IL is equal to ISC. Similarly, we can find out the next we can find out another one is IA is equal to ISH. Sorry, here IA is equal to ISH. Again ISH is equal to VT plus IA, VT plus ISC or AC by RSH. VT plus ISC or AC plus RSH. Similarly, we can find out short shunt motor. So EB is equal to VT minus IA RA minus ISC RAC minus brush drop. Here also we can same as what is the same here? Directions. Directions is so IA is equal to IL minus ISH. So here IL is equal to ISC. So ISH is equal to VT here plus here VT minus ISC RAC by RSH. Again we can find out the long shunt. EG is equal to VT plus long shunt. Long shunt IA RA plus RAC. Here IA is equal to IAC. IA is equal to ISC. So let us IA is equal to ISC is equal to what happened? IL plus ISH. So what is the ISH? ISH is equal to V by RSH. Now we can find out the final equation. Here long shunt generator EB is equal to VT minus IA into RA plus RSH. Sorry, RSC. RSC. So we can find out IA is equal to ISC. So that is nothing but IL minus ISH. So that is ISH is equal to V by RSH. ISH. It is V by RSH. So this is the voltage and current equations of generator and motors. Classification of DC generators and DC motors topics. Thank you.